Class 11 Chemistry Chapter 1 Some Basic Concepts of Chemistry Part 2. What is meant by atomic mass? Atomic mass means mass of an atom. An atom is extremely small in size and therefore its mass is also extremely small. These days, scientists they have sophisticated techniques to find out exact mass of an atom. But in earlier times, scientists they used to find out the mass of an atom by comparing it with some standard atom. Scientists chose C12, carbon 12, which is an isotope of carbon as the standard atom and compared masses of all the atoms of other elements with 1/12 mass of C12. C12 atom is the isotope of carbon. C12 isotope of carbon assigned atomic mass of 12U. U is unified mass. It is also known as atomic mass unit. And therefore 1U is equal to 1/12 of C12. Okay. So now we can define relative atomic mass as how much time one atom of element is heavier than 1/12 mass of C12. Okay, for example, one atom of oxygen is 16 times heavier than 1/12 mass of C12 and therefore atomic mass of oxygen is 16U. Similarly, sodium, its atomic mass is 23U, which shows that one atom of sodium is 23 times heavier than 1/12 mass of C12. Magnesium, its atomic mass is 24U. Magnesium is one atom of magnesium is 24 times heavier than 1/12 mass of C12. So this is known as the relative atomic mass. Okay, children, hope you have understood. Look here, children, I have taken example of potassium. The mass of one atom of potassium is 39 times heavier than 1/12 mass of C12. So the relative atomic mass for one atom of potassium is 39U, which should be 39U, unified mass. What is molecular mass? Molecular mass means mass of a molecule. Now we can find mass of a molecule by comparing it with 1/12 mass of C12. This is known as relative molecular mass, RMM. Relative molecular mass tells us how many times the mass of one molecule of any compound is heavier than 1/12 mass of C12. For example, one molecule of water is 18 times heavier than 1/12 mass of C12 and therefore mass of water is 18U. One molecule of carbon dioxide is 44 times heavier than 1/12 mass of C12. Therefore, its molecular mass is 44 U. How to calculate molecular mass? We can calculate molecular mass by adding atomic masses of all the atoms present in a molecule. For example, we can calculate molecular mass of water as follows. Water is H2O. Water contains 2 atoms of hydrogen and 1 atom of oxygen. So we can find out the molecular mass by adding atomic masses of 2 hydrogen atoms and 1 oxygen atom. So it will be 2 atoms of hydrogen are there into atomic mass of hydrogen plus how many atoms of oxygen? 1 atom of oxygen. So 1 into atomic mass of oxygen atom. So it comes out to be 2 into 1 plus 1 into 16. So that comes out to be 18 grams. 18U, you can say 18U, which is the molecular mass of water. Now let us calculate molecular mass of carbon dioxide. Carbon dioxide is CO2. Carbon dioxide contains 1 atom of carbon. So 1 into atomic mass of carbon. 2 atoms of oxygen are there in carbon dioxide. So it will be 2 into atomic mass of oxygen atom. So it comes out to be mass of carbon atomic mass is 2, 1 into 1 atom of carbon into atomic mass of carbon. It's 12. 12U plus 2 into atomic mass of oxygen comes out to be 16. So 12 plus 32, it's 12 plus 32, which is 44U. This is how we calculate the molecular mass. It's 12U plus 2 into atomic mass of oxygen comes out to be 16. So 12 plus 32, It's 12 plus 32, which is 44 U. This is how we calculate the molecular mass. Mole concept. What is a mole? Mole represents a number similar to that of dozen. We know that 1 dozen is 12 numbers. Similarly, 1 mole is equal to 6.022 into 10 raised to 23 numbers. It can be anything. If we are talking about apples, 1 mole of apple is equal to, it represents 6.022 into 10 raised to 23 apples. If we are talking about atoms, 1 mole of atom represents 6.022 into 10 raised to 23 atoms. If we are talking about molecules, 1 mole of molecule represents 6.022 into 10 raised to 23 molecules. This number 6.022 into 10 raised to 23, this number is known as the Avogadro's number, is known as the Avogadro's number. One mole of atom, 1 mole of atom is equal to gram atomic mass. 1 mole of, I'll take example of oxygen atom. 1 mole of oxygen atom is equal to atomic mass 16 U, gram atomic mass 16 grams. Atomic mass when expressed in grams is known as gram atomic mass. Okay, now 1 mole of any atom also contains Avogadro number of particles. 16 grams, 1 mole of oxygen atom is equal to its gram atomic mass. It contains Avogadro number of particles. Avogadro number of particles means 6.022 into 10 raised to 23 particles. Similarly, 1 mole of molecules, 1 mole of molecules is equal to its gram molecular mass. Molecular mass expressed in grams is known as gram molecular mass. Example, 1 mole of oxygen molecule is equal to, molecular mass of oxygen is 32 U. Gram molecular mass is 32 grams. It contains how many particles? 1 mole of any atom, any molecule will always contain 6.022 into 10 raised to 23 particles, which is known as Avogadro's number. Clear, children? So 1 mole of any atom, that will be equal to its gram atomic mass, and that will have Avogadro's number of atoms. 1 mole of molecules will be equal to its gram molecular mass, and that will possess Avogadro number of molecules. Moles, it can be converted to mass, volume, and particles. moles can be converted to particles by multiplying number of moles and Avogadro's number. Particles can be converted to moles by dividing number of particles by Avogadro's number into number of moles. Moles can be converted to mass by multiplying number of moles and molar mass. Mass can be converted back to moles by dividing given mass by molar mass. Moles can be converted to volume by multiplying number of moles into volume at STP. Volume can be converted back to moles by dividing given volume by standard volume. Okay, standard volume is volume of gas occupies 22.4 liters at STP conditions. Children, here you can see the important formulae. Number of moles N is equal to given mass upon atomic mass or the molecular mass. Number of moles is equal to volume of gas at normal temperature pressure conditions upon standard conditions. Volume of gas under standard conditions. The number of moles number of particles upon Avogadro's number, weight of one atom of one element, atomic mass upon Avogadro's number, weight of one molecule of a compound is equal to molecular mass upon Avogadro's number. Okay, now we will solve some problems based on this. Children, here you can see the important formulae. Number of moles N is equal to given mass upon atomic mass or the molecular mass. Number of moles is equal to volume of gas at normal temperature pressure conditions upon standard conditions. Volume of gas under standard conditions. The number of moles number of particles upon Avogadro's number, weight of one atom of one element, atomic mass upon Avogadro's number, weight of one molecule of a compound is equal to molecular mass upon Avogadro's number. Okay, now we will solve some problems based on the calculate number of atoms in 3.2 grams sulfur. Okay, so how to do this? Number of atoms is equal to number of atoms is equal to number of moles into Avogadro's number. So number of atoms will be how to calculate moles, given mass upon molar mass into Avogadro number. So that comes out to be 0.1 into 6.022 into 10 raised to 23 atoms. Find volume of 26 grams of oxygen molecule. So for that, children, we have to calculate number of moles first. Okay, we'll use the formula volume is equal to number of moles into molar volume. Molar volume is the volume of the gas at STP, molar volume. So it comes out to be 26 divided by 32 into molar volume. That's 22.4 liters. 22.4 liters. So the answer will be somewhat closer to 1, 3, 6. Okay, using calculator, it comes out to be 18.1 liters. Okay, so this is the answer.